Hello everyone. I am doing previous year questions of strength of material which are already came in GATE Engineering Services and Civil Services examination. Uh, Today I am going to deal few questions of IAS exam. The topic will be stress and strain. This is about myself. Okay, so let's see today's. Okay, so this question number one for today's lecture is that. Let's read the question. A heavy uniform rod of length L and material density del is hung vertically with its top end rigidly fixed. How is the total elongation of the bar under its own weight expressed? Okay, देखिए इसमें own weight पूछ रहा है due to own weight. So if you have watched my previous videos, so you will find that I have already deal question of engineering services. So it is like PL by 2 AE. Okay, that is for self weight. Okay, so this is for self weight that I am talking about. WL by 2 AE. Okay, so weight को हमको इस फॉर्म में लिख देना है. Okay, mg weight is what is it is mg. Okay, m को वॉल्यूम के टर्म में लिखो. Okay, so it will be del al g l. Okay, if you simplify this you will get del l square g by 2 e. So which is the answer is D. Okay, तो sometime ऐसे भी पूछ लेता, so don't worry for that. So just remember this del l square g by 2 e. अब इसमें क्या होगा, एग्जाम में गेट के एग्जाम में इसकी वैल्यूज दे देगा और फिर आपको कुछ न्यूमेरिकल वैल्यू दे देगा, पूछ लेगा, या फिर उसमें फिलिंग द ब्लैंक्स भी आते हैं तो वो भी दे सकता है. नेक्स्ट, a rod of length L and cross-sectional area A rotated about an axis passing through one end of the rod. The extension produced in the rod due to the centrifugal force is omega. The W is the weight of the rod per unit length. W is angular velocity of rotating rod. Okay, see, ये इसको देखिए आपको ये रोटेट भी हो रहा है तो इसका डायरेक्ट फार्मूला होता है बी. इसको आपको उतना सिंप्लीफाई करने की जरूरत नहीं है. ओके, अगर आप इवन गेट का एग्जाम दे रहे हो, इंजीनियरिंग सर्विसेज का, आप यू जस्ट रिमेंबर, इसको याद कर लो. ओके, दैट इज डब्ल्यू स्क्वायर ओमेगा स्क्वायर डब्ल्यू एल को एल क्यू बाई 3 GE. Okay, so if you are going to solving for this problem, it will take a lot of time. Anyway, whenever I will deal with the theory part of strength of material, so there I will try to solve this problem. Okay, here I am not going to solve. You just remember this answer here. Okay, so once I will do the theory part, please watch that video also, so you will come to know how this formula will come. Next, okay, tapered rod आ गया. Okay, so इसका क्वेश्चन हम लोगों ने काफी ढेर सारा किया हुआ है. Okay, so rod of length L tapers uniformly from a diameter D1 to the diameter D2 and carries an axial tensile load of P. The extension of the rod is, okay, so tapered rod है उसमें extension पूछ रहा है. So the 4PL by pi E D1 D2. Okay, answer is actually A. Okay, so this is the extension in tapered rod. Okay, PL by pi by 4 इसको D1 D2 E, इसको आप 4 को ऊपर लेते जाओ तो 4PL by pi D1 D2 E. Okay, so that is given here. नेक्स्ट क्वेश्चन, ये भी क्वेश्चन हम लोग इंजीनियरिंग सर्विसेज वाले क्वेश्चन में देखे हुए हैं. ओके, सो पॉइजन्स रेशियो इन द केस ऑफ एन इंजीनियरिंग मटेरियल अंडर यूनिडायरेक्शनल स्ट्रेस in the x direction, the Poisson's ratio is equal to, answer is A, epsilon y by epsilon x. Yeah, next assertion reason आ गया. Let's read that the Poisson's ratio of material is a measure of its ductility for every linear strain in the direction of force. Poisson's ratio of material gives the lateral strain in direction perpendicular to the direction of force. ओके सी ये चीज़ तो गलत है. फर्स्ट इज गलत, लाइक no, Poisson's ratio of material measure ductility. No, it does not measure the ductility. This is wrong. Okay, तो अगर आपको assertion पता है wrong है तो D आंसर हो जाएगा. Okay, but this reason is correct. Next, Poisson's ratio is measure of lateral strain in the direction perpendicular to and in terms of linear strain. Okay. The nature of lateral strain in a uniaxial load bar is opposite to the linear strain. इसमें दोनों ही करेक्ट है. ओके, ये दिस इज एब्सोल्युटली करेक्ट. ओके, Poisson's ratio is the measure of lateral strain in all the direction perpendicular to and in terms of linear strain. This is absolutely correct. The nature of lateral strain in a uniaxial loaded bar is opposite to that of the linear strain. Yes, this is also correct. Okay, but this is not the correct explanation of A. So that's why answer is B. Both is correct, but this reason is not correct explanation of assertion. Okay, next question. Okay, elasticity and plasticity का question है. A weight fall on a plunger fitted in a container filled with oil, thereby producing a pressure of 1.5 Newton per mm square in the oil. The bulk modulus of oil is 28800 Newton per meter square. Given this situation, the volumetric compressive strain produced in oil will be. Okay, the volumetric strain की बात है. So it's nothing but, see, the bulk modulus of elasticity is what? That is K is P by volumetric strain. Okay, so we can write, volumetric strain, that is epsilon V is P by K. Okay, this is P, this is K. So both is given, P is given, K is given. Okay, just put here, just divide that, you get the answer. That is 535 into 20 minus 6. So its answer is D. Okay. Next question. For a linearly elastic, isotropic and homogeneous material, the number of elastic constant required to relate stress and strain. Okay, ये question already हम लोग इससे पहले वाले जो lectures है उसमें कर चुके हैं. Okay, so if you have already watched those videos, you can easily solve this question. Answer is actually A. दो की requirement होती है. कोई दो अगर हमें पता है तो we can know the others. Next, ये भी उसी क्वेश्चन को दूसरे फॉर्म में लिख रहा है. The independent elastic constant for homogeneous and isotropic materials are D, E and G. Okay. Next question, and I think last question for this video. The unit of elastic modulus is same as, okay, shear modulus, pressure, strain वगैरह तो होगा नहीं. इलास्टिक यूनिट की बात कर रहा है, स्ट्रेन तो होगा नहीं. ओके, सो ये भी नहीं होगा. ओके, इसमें भी स्ट्रेन दिया, ये भी नहीं होगा. ओके, shear फोर्स, ये भी नहीं होगा. ओके, फोर्स का न्यूटन होगा. एक्चुअली ए. ओके, इसमें स्ट्रेन है, ये भी नहीं होगा. इसमें स्ट्रेन, इसमें नहीं होगा. इसमें फोर्स, ये भी नहीं होगा. ओके, तो सबका न्यूटन पर मीटर स्क्वायर. प्रेशर का भी न्यूटन पर मीटर स्क्वायर होता है, shear modulus का भी होता है, स्ट्रेस का भी होता है. ओके, सो इट्स आंसर इज ए. Okay, so this was the end of IES question of stress and strain. Thank you for watching. Bye.